Sequence and series. We will see how the formulas in AP, GP is used to our benefit. Firstly, we'll see AP. What an AP is there? You know it very well that it is a series in which difference between two consecutive terms is always constant. So D is an minus an minus 1. Here you see, if I put n equal to 5, it will be a5 minus a4. It can be a6 minus a5, a10 minus a9, which is constant all the time, then it is an AP. So you can easily identify AP. Take the series 2, 5, 8, 11. See, difference between the consecutive terms is whether constant or not constant. If it is constant, it is an AP. See, difference is 3 here between second and first, between third and second, like this. The nth term of an AP is given as a plus n minus 1 into d. A being the first term, d being the common difference, an is the value of the nth term, and n is the term which we are talking about. Suppose we are talking about fifth term, then an is the value of the fifth term and n is 5. So you see 4 variables are here in the equation an, and d. If anyhow you know 3 variables, you can find the fourth easily. Suppose 2 variables are known, so you need 2 equations to get in the terms of 2 unknown variables, and you will solve them and get it. Now sum of n terms in AP is given as n by 2, 2a plus n minus 1 into d. See again here 4 variables are there, n, a, d, sn. You know 3 variables, you can find the fourth one easily. So we can easily find the sum of n terms of the AP using this formula. We know, if we know a, n and d, we can get it easily. Now what is AM? AM is the thing which when inserted between two numbers make the complete series in AP. This is very basic definition of AM. If you remember this, you will easily be able to solve the questions regarding AM. Suppose we are inserting 3 AMs A1, A2, A3 between A and B. Now see, this series is going to be in AP. This is the basic thing. If you remember, you can easily find the AMs, relation between the AMs and the other unknown things. See what is known here in the AP. The first term is A and the last term, which is going to be the fifth term here. See, we know A and B is the fifth term. You just count A, 1, 2, 3, 4 and B is the fifth term. For fifth term, if I have to write, then B can be written as A plus 4D. A is the first term and D is the common difference of that AP. We can now get the value of D very easily, which is B minus A by 4. Now we got the value of D. We can easily find A1, A2, A3 because A1 is the second term of the AP. A2 is the third term. Likewise, so A1 is A plus D. We know A we got the value of D, we can find A1 easily. Same way we can find the other AMs E2 and A3 very easily. So I think you got the concept of the AMs. Now we are inserting n AMs between two numbers A and B. See, we have inserted the AMs, so the series is in AP. Okay, B is not clear, but it is B. See, A, B, the two terms, between them we have inserted NAMs A1, A2, A3 up to AN. Now we see that how after inserting this we can get the values of the different AMs. The basic thing all the time you have to remember, again and again I am saying that inserting the AMs make the series in AP. So in the previous example we have inserted NAMs, we got it. Now we will see what is GP. GP is that series in which ratio of two consecutive terms is always constant. That means AN by AN minus 1 is constant. What does this mean? You can say A3 by A2, A5 by A4, A10 by A9, always it is constant. The nth term of a GP is given as AR to the power n minus 1. So two variables are here, A, R. Same way you can find the sum of n terms in GP as AR to the power n minus 1 by R minus 1. Here R is greater than 1. If R is less than 1, you can write the formula as A1 minus R to the power n by 1 minus R. So not very specific, you can easily do. Sum of infinite terms in a decreasing GP. Be careful, increasing GP we cannot find, is A by 1 minus R. A being the first term and R being the common ratio. So if we have to find the sum of infinite many terms of a decreasing GP, we can apply this formula A by 1 minus R to find sum up to infinite many terms of a GP which is decreasing. If it is increasing, it is impossible to find because every time it is getting increased and increased. So no formula for finding the infinite many terms sum, because in that case it will be infinity. So be careful, R should be less than equal to 1. Less than is not equal to, if it is equal to 1 it is going to be infinity. So we can easily find the sum of n terms, this infinity sum of infinite many terms. Now we see GM. As we learnt in AM, that when inserting AM make the series in AP. So GM is that thing which when inserted between two numbers make the series in GP. We apply the basic concept of the GP, we will easily get the GMs as we got the AMs earlier. So we have inserted n GMs between A and B. So the series is going to be in GP. So A, G1, G2, G3 up to Gn and B is making a series which is in GP. We apply the basic concept, we will get the value of the GMs or other unknown thing which we have to find here in the question. I'm just taking one example here. See, if it is given that 3 minus k 8, is in AP, a particular type of question, how the questions are being asked. I'm going to see some of them. Now, three terms are in AP. What basic concept you have to apply? Second term minus first term is equal to third term minus second term. You apply this thing, you will get the value of the unknown very easily. So, anytime if you get three terms being an AP, just apply the basic concept. Always remember this: second minus first is equal to third minus second. Suppose question is given that fifth term, that is a plus 4d, is equal to 9, and 10th term, that is a plus 9d, is equal to 12. That means two statements given regarding a and d. So if we solve them simultaneously, we can get the values of a and d. Once we know the value of a and d, everything is done about the AP. Very important thing in the AP is the first term and the common difference. So anyhow, try to find a and d at the first instance. You will get everything fall to your foot automatically. Very easy. One more example I am taking. If the sum is given as an square plus bn plus c, sum of a series is represented in this fashion, you have to check which type of series it is representing. One example I am taking: 5n square plus 4n plus 9. Sum of the series is given in this fashion. We have to see which type of series is being represented by that formula. We will find an, the nth term of the series, which is Sn minus 1. Sn minus 1 is going to give you the value of the nth term. If we get the nth term and we find the difference between two consecutive terms, which is an minus 1. If it is somehow coming out to be constant, that means the series is guaranteed in AP, because the difference between two consecutive terms is constant. What do you mean by the word constant? Means that no n is there. That is, it is independent of value of n. It is remaining same irrespective of the value of the n. So if we have to, it's given that sum of n terms of two APs is given, n by 2 2a plus n minus 1 into d divided by the sum of n terms of the second GP as n by 2 2a. You can write capital A here because this is another AP, plus n minus 1 into capital D. So this is the ratio of sum of n terms of two different APs, and we have to find the ratio of certain terms of the two APs. If it is given in a particular question 2n plus 1 divided by 5n minus 3, that is the ratio of nth terms of two APs is this. We have to find their ratio of 11th term, suppose. Okay, how we will proceed? A11 by, you can write A dash 11, okay, because two different APs. So what we need? A11 is A plus 10D, and A dash 11 will be A capital A plus, you can write 10 into capital D. So this is the given resource above that is Sn by S test n, we have to make use of that to get the value of the ratio of their 11th term. So see, if we have to make the given series as what we want, we divide both numerator and denominator by 2. Why? Because we want a, we don't want 2a. It is going to be a plus n minus 1 by 2 into d by capital A plus n minus 1 divided by 2 capital D is equal to whatever is given you right here, 2n plus 1 by 5n minus 3. Okay, now it is little bit matching what we want for n minus 1 by 2. We want 10. If somehow by putting the value of n anything we are getting 10 in place of n minus 1 by 2, we will get what we want, that is a plus 10d by e plus 10d, like this. So if I put n equal to 21, see it is going to be 21 minus 1, 20 by 2 is 10. How we are getting? We were just putting n minus 1 by 2 is equal to 10. So n is coming out to be 21. So if we just put n equal to 21, it will be 2 into 21 plus 1 by 5 into 21 minus 3. So we will get the ratio of their 11th term very easily. This is the way we proceed and get the things done. So if we do it very carefully, the things become very easier for us. Just keep in view that our basics should be very strong. Now see, it is given that fifth term of a GP is, as we are discussing certain type of questions in AP and GP. So one example I am taking, the fifth term of a GP, that is a into r to the power 4. Anyhow, if we have to find certain term, we can do. Very common question I am going to do, and this is very important question as well, that is 555, 555, 5555, like that. We will see which series it is falling into. Once we identify which type of series is this, we can apply the formula and get the things easily. We follow 9 method here. I am discussing here in such type of question. Firstly, you take, what can you do? You can take 5 common. For 5 is taken common everywhere. For we can divide everything by 5. If it is 66 like this, we'll take 6 common. It is 77, 777, we will take 7. Anyhow, we have to make it 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, like that. Okay, so that we will make the series convenient to be identified as one of the series AP or GP. On taking 5 common, it is giving us 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, like that up to n terms is going to be. Now, what can we do? I said you will follow 9 method. So I will divide by 9 and multiply the whole thing by 9. Why? Because this will make a series to be identified easily. So it is 999, 999, like that up to n terms it is going to be. Further, you see 9 can be written as 10 minus 1. Easily you can write 99. That can be written as, you usually know, 100 minus 1. 999 is 1000 minus 1. Like that. Now you see that we are identifying the series easily. Okay, this is n terms here, it's not n square. Okay, see, it is 5 by 9 outside. So if we are collecting 10, 100, 1000 at one place up to n terms, and see how many ones are there. 1, 2, 3, like that. How many ones are there? That are n ones are there. So it is minus n. Very important. Be careful. Okay. Now this series is in GP 10, 100, 1000. Common ratio is 10. First term is 10. So A r to the power n, that is 10 to the power n, because it is 10 to the power n minus 1 by r minus 1, that is 10 minus 1, 9. And it is n minus n. Don't forget writing n. This is important. Okay. Now we will encounter some different type of questions on mixture of the series. We have to see the spatial sequence. We see that Sn is actually the sum of all terms, that is summation of Tn. This is to be applied and we will get the sum of the n terms of a series, which is not just a pure AP or GP, that is a mixture of the things. So how can we identify the things? If we are getting the nth term, we have to remember certain formula. Summation n is n into n plus 1 by 2. Same way, you have to remember summation n square, which is n into n plus 1 into 2n plus 1 by 6, that you know. And summation n cube is going to be the n into n plus 1 by 2 complete whole square. So you can say summation n square is actually the whole square of summation n. If you remember these things, you can easily find Sn by using Sn is summation of Tn. If Tn is given as 2n minus 3, you can easily find Sn as summation of Tn. So summation of Tn can be written here as 2 outside, we can take summation n minus 3 summation. So 2 summation n is, we know it, n into n plus 1 by 2. And summation 3 is going to be 3, we are adding n times. So what is this? If you are adding 3 2 times, that is 3 into 2. 5 times, that is 3 into 5. So n times 3n. Be careful that we are finding summation of 3. People used to write 3. No, it is not 3. It is 3n. 5, it will be 5n, like that. You just be careful. You won't make mistake. So you can easily find Sn. Suppose a series is given and the nth term is not given. Firstly, we have to find the nth term. 1 into 2 square plus 2 into 3 square plus 3 into 4 square, like this. The series is now easily identifiable. See, the first term 1, 2, 3 is in AP. So the nth term of the series will be the first term as the nth term of 1, 2, 3. 1 first term, second 2, third 3. So nth it will be n. Very easily you can write. So the first term of the nth term will be, by seeing this, the pattern is going to be n. Okay. Now I have to see what is how we are finding the nth term. You see, this is 1, 2, 3 is in AP, so the nth term of the AP will be A plus n minus 1 into D. Luckily it is coming out to be n here, but you follow this technique, finding the nth term of the AP. If some different series is given, you will easily, this is a generalized view. See, second term is 2, 3, 4, so it will be, nth term will be 2 plus n minus 1 into common difference is 1 and the whole square of the second term. So what it is coming out to be, see here, this is n and this is n plus 1 whole square. You just simplify this. It is going to be n square 2n plus 1 like this. If you just write n square plus 2n plus 1, you just multiply n with the thing, it is n cube plus 2n square plus n. So this is the nth term of the given series. Now we can find Sn easily. Sn is what? Summation of Tn. So we'll write summation of the Tn, which is summation n cube plus 2 we can take outside, summation n square plus summation n. We know the formula of summation n cube, summation n square, summation n. We will put it here and we will get the nth term of the given series. It is very easy. If we getting nth term of the any series, we can find the sum of n terms of the series by applying the formula Sn is equal to summation of Tn. Now I think that spatial sequence is clear. You just have to remember the formula I have given you, summation n square, summation n cube. Now we will see which a series which is not a spatial sequence but known as AZP, which is arithmetico-geometric progression. Okay, that we will be seeing. Just see this one series, 2 into 3 plus 3 into 3 plus 4 into 3. What I have to do? We'll identify the first item, 2, 3, 4, which is in an AP. So the nth term will contain the first item as the nth term of the AP 2, 3, 4. Okay, so the nth term of that will be n plus 1, and that second term is 3 square, 3 square, 3 cube, 3, 4 like that. So it is 3 to the power n plus 1. So once the nth term is known, okay, in solving that AZP, this is first AP and the second is in GP, we just multiply with the common ratio of the series with the S and just write the things leaving one's place. So the first term is 2 into, it was 3 square, so it is 3 cube like that. And if we have left the one place at the beginning, so we have to write extra one place in the end, and the nth term of the series after multiplication with 3 is n plus 1 into 3 to the power n plus 2. Now we will go for subtraction. We will subtract. Little bit dirty line, but you see what the concept we are following here. Solving AZP, it is going to be minus 2s, s minus 3s is minus 2s. First term is left over and see the last term is left over. In between, how many terms are there? N minus 1 terms are there. Be careful, first term and the last term is not getting involved in the process of addition or subtraction. The first term I will write as it is, 2 into 3 square plus, now on subtraction what it is going to be, 3 minus 2, 1 into 3 cube plus 1 into 3 4, like this. How many terms are there? As I have left one item, so n minus 1 terms. Be careful, all the time it is n minus 1 terms, and we have identified the series. On subtraction it is becoming a pure GP. Last term is left over as it is, n plus 1, 3 to the power n plus 2. Now we have identified the in-between series to be in GP. We apply that formula and we will get the S. So following this method we can find the sum of an AGP series, that is arithmetico-geometric series involving the terms in AP as well as in GP. So the technique, I said you multiply R with S, just write the things, leaving one space, one extra, how it will go on, and we can get easily S. So AGP is now very much clear to you. We have gone for spatial sequence and I have discussed the AGP as well. Now we will see what is HP. HP is the series whose reciprocal terms are in AP. So 1 by 2, 1 by 5, 1 by 8, the reciprocal is 2, 5, 8 is in AP. That means 1 by 2, 1 by 5, 1 by 8 is in HP. We don't have any separate formula for HP. We just take help of the AP to find anything about HP. We have to find any term, that means fifth term, sixth term. Firstly, we will convert the series in AP. We'll find the fifth, sixth or whatever term is being asked in the AP, and then we'll just reciprocate it and the HP term will be obtained. HM is the thing, as I discussed, AM and GM is when inserted between two numbers make the series in HP. As HM between two numbers is 2AB by A plus B. You just remember, as already you know that AM between two numbers, you know it, A plus B by 2. And same way you know what is the GM between two numbers, that is under root AB. So SP we don't have to give extra weightage, we are just confident in AP and GP. SP is not something extra. Hope you understood the basic revision on sequence series. This is your loving Santosh Kumar, and you know my number, it is 90313 58558.